Welcome class to this video on the interior and exterior angles of quadrilaterals. The goal of this video will be to determine the properties and relationships of the interior and exterior angles of quadrilaterals. First, let's look at what a quadrilateral is. Quadrilateral just means four sides. Quad means four and lateral means side. A quadrilateral has four sides. It is two-dimensional, which means it's a flat shape. It's closed, meaning the lines all join up, and it always has straight sides. Now that we know the definition of quadrilaterals, we can review its angle properties. The sum of the interior angles of a quadrilateral is 360 degrees. What that means is the angles which you can see inside that quadrilateral on the screen labeled A, B, C, and D, if added up, will equal to 360 degrees. And this is true no matter the shape of the quadrilateral. If it has four straight sides, if the shape has four straight sides and it's two-dimensional, the sum of the interior angles of that shape will be 360 degrees. The sum of the exterior angles of a quadrilateral is 360 degrees as well. That means if you add up the exterior angles labeled in that second shape there, A, B, C, and D, you would get 360 degrees. Now you should know that in fact the sum of the exterior angles of any polygon is going to equal 360 degrees, and therefore this is a property that is not unique to quadrilaterals. Very briefly, I'd like to turn your attention to a few specific kinds of quadrilaterals. So first let's talk about rectangles and squares. You're all familiar with rectangles and squares, I'm sure. But one thing I wanted to point out and have us recall is that this little box here means that this angle is 90 degrees. And so you can see a rectangle consists of four 90-degree angles. It also has sides where the opposite sides are equal to one another. So you can see the two red lines and the two blue lines are going to be equal to one another. Another important thing to know about rectangles is that a square is in fact a rectangle. And it is because it meets the definition. It has the opposite sides that are equal to each other, and it has the four 90-degree angles. The difference, or what makes a square special, is that all the sides are equal. Before we can start working on some example problems, we need to know the characteristics of one last quadrilateral. Here we have a kite. A kite is a flat shape with four straight sides that has two pairs of sides. Each pair is made up of two adjacent sides they meet that are equal in length. Also, the angles are equal where the pairs meet. And so, if you look at the kite, you can see the pairs are demarcated by their different colors. So here's one pair, it's in blue, and here's the other pair, it's in red. And where the two pairs meet, you have these angles here, A, labeled A and A, and those angles are opposite of one another, and they are equal. So you can see the angles are equal where the pairs meet. That's going to be very important for us as we do some practice problems together. Now that we know some general facts about quadrilaterals and a couple of facts about specific kinds of quadrilaterals, we have enough information to begin working on the kinds of plane geometry questions you can see on your screen. When working on these problems, we will follow three steps. The first step is you must observe and take note of the shapes present in the question. The second step is to recall facts that are relevant to solving the problem. And the third step is to apply basic arithmetic like addition, subtraction, multiplication, and division in order to solve. Looking at question A, I can see that the shape is a quadrilateral. I can also see that the quadrilateral has two angles which are 90 degrees. So I know three angles of the quadrilateral, and I'm trying to find the fourth angle. What do I know about quadrilateral that's relevant to solving this problem? I know that the sum of the interior angles of a quadrilateral are 360. Therefore, to solve this question, I simply do x is equal to 360, subtract 90 for one angle, 90 for the other angle, and 55 for the third known angle. And I then get 125 degrees. Looking at question B, it's a very similar kind of question. Again, I can see a quadrilateral. I know three of the angles, and I'm trying to find the fourth. When that is the case, I simply use x is equal to 360, subtract the three known angles, and when I do that subtraction, I get x is equal to 80 degrees. Question C. In this question, I'm given three exterior angles. The relevant fact of a quadrilateral. The relevant fact I know is that the sum of the exterior angles of a quadrilateral or any polygon is 360. And since I know three of those four angles, I can simply do x is equal to 360, subtract 125, subtract 128, subtract 75, and I get x is equal to 32 degrees. D, just like C, has given me 3 out of the 4 exterior angles of a quadrilateral, and I know that those exterior angles add up to 360, and since I know 3 of them, I can subtract those 3 known ones from 360 to find the unknown angle. 360 subtract 100, subtract 90, subtract 84, and I get that x is equal to 86 degrees. Question E. I can see here that I have a specific kind of quadrilateral called a kite. And as we learned earlier, a kite consists of 2 pairs of sides. So here's one pair in red, and here's the other pair. And where these pairs meet, they have angles which are opposite of one another and are equal. And so you can see on this side we have 126. It means that over here this must also be 126 degrees. Now, the other thing I can observe here is that I have a supplementary angle created by the exterior angle and the interior angle of the polygon. And this is true anytime you extend a line to create an exterior angle of a polygon. You create a supplementary angle, and I show you over here in question D. These are all supplementary angles. And that's useful for us to know because if I know one of the angles of a supplementary pair, I can simply find the other by doing B is equal to 180 subtract the known angle. So 180 subtract 126, and we get 54 degrees. Question F. Question F is also a kite. It also has the opposite angles which are equal, which means this side here must be 136 degrees. Now, what I'm being asked to find is this angle over here. And I can use 2 facts that I've learned before in order to find it. The first fact I can use is I can find this angle inside here, relying on the idea or the fact that the sum of the interior angles of a quadrilateral is 360. So I can find this angle by simply doing, and I'm going to label it x, I can find this angle by doing 360 subtract 32 subtract 136 subtract 136. Right, and that works because I have 3 of the 4 angles, and I know the sum is 360, so I can subtract those 3 known angles from 360, and in this case I will get 56 degrees. Oops, not 560, but 56 degrees. Now, recall what we just discussed, which is that anytime I create an exterior angle by extending the line of a polygon, I have now created a supplementary pair. I know that x is equal to 56, and I'm trying to find D, so I can simply do 180 subtract 56, and I get D is equal to 124 degrees. Hopefully these practice questions have helped you and will be sufficient to allow you to answer the rest of the questions in this handout. Good luck.